Good morning, everyone. I'm going to be doing this science interactivity Winds Across the Globe on the video for you so that you know exactly what's expected of you as far as science for today. I'm just going to try to move my camera up so that it's not in the way when we're trying to do the activity. So, facts about winds. Christopher Columbus discovered the North Atlantic global winds on a voyage to the Americas. Global winds over ocean waters north of Antarctica average speeds of 9 miles per second or higher. Offshore, electricity generating wind turbines were first installed in 1991 off the coast of Denmark. So then we're going to go to the next page. And you can see that I already put the wind currents in there. So towards the wind goes towards the equator down here and towards the equator up from the bottom. And then at around 60 degrees, the wind goes towards the 60 degrees. So 60 degrees down here, it also goes down. And what you're going to do is just click on these little arrows and drag them up and drop them into the correct boxes, which I had already done for you so that you can watch the video and then pause it and you'll be able to see exactly where the wind currents go. Then it's going to ask you a couple questions. So I'm going to move this again here so that you can just see the answers here. Use your model to describe the global pattern of atmospheric circulation. Winds tend to blow in the same direction within the latitude belt across Earth. They follow curved paths that either blow toward the equator or toward the latitude lines at 60 degrees north or south. That was what I was showing you on the previous page, that the winds blow toward the equator or towards those latitude lines, and they blow in the same direction across the latitude belt. Number 2, why is your model useful for describing winds over the oceans, but not necessarily the winds that blow over landforms such as coastlines or mountains? While over land, winds often form due to local effects such as the uneven heating of land and water and lands at different elevations. With no landforms, the wind pattern of the ocean is more consistent and predictable. So the land changes the way that the wind blows. Because of the ocean, there's no land, the wind always blows the same ways. And then the last page, circulation application. And you can see here again that they gave you a model of what we put on page 2. So use your model to describe how the unequal heating of Earth and Earth's rotation causes Earth's patterns of atmospheric circulation. The sun heats Earth's surfaces unevenly, which causes differences in temperature and pressure above the surface. Wind blows because of differences in air pressure. Latitude determines the patterns of heating. Therefore, global winds form a latitudinal pattern of wind belts. If Earth were stationary, wind belts would blow either due south or due north. Because Earth rotates, the winds follow curved paths. So the Earth is constantly rotating, and you can see here that because the Earth spins around, and we know that the Earth's winds are curved. But also at the same time, the Earth is a circle like a ball. So different parts are going to be hotter than others because they're closer to the sun, as we learned in previous lessons. So I hope that this helps you. If you have any questions, just call or text me. And I'm going to post this on YouTube so that you guys can use it to finish your science activity.